Hello everyone, I am Kavya Manohar, Speech Technology Researcher at APJ Abdul Kalam Technological University, Kerala, India. My work focuses on automatic speech recognition for Malayalam language, and I work under the supervision of Dr. A.R. Jayan and Dr. Rajiv Rajan. Today in this presentation, I will explain our work on analyzing quantitatively the morphological complexity of Malayalam language. Malayalam is a language spoken predominantly in the state of Kerala, India, with about 38 million native speakers. Morphological complexity of any language implies its complex word formation mechanism by inflections, derivations, and compounding. Malayalam belongs to the family of Dravidian languages which undergo such morphologically complex word formation mechanisms, resulting in a practically infinite word vocabulary. This table shows such examples. The first two rows of the table indicate nominal inflections by locative and associative suffixes respectively. And the third row indicates a compound word formation by the combination of two noun forms. And the final row indicates the associative suffix being added to the already agglutinated word form which we saw in row 3. And the same way of multiple levels of agglutinations and compounding can happen to verbs and nouns in Malayalam. While working on various aspects of large vocabulary speech recognition for Malayalam, we have come across the requirement to have very large pronunciation lexicons to handle the out-of-vocabulary scenarios. This has motivated us to investigate the morphological complexity of Malayalam and to quantify it. So, how do we measure and quantify the morphological complexity? Well, there is no one single measure that measures morphological complexity for all languages, but there are different techniques. One is based on assessments of linguistic typology of the language, but this involves human expert judgments and requires a strong linguistic know-how, because one has to analyze word forms in terms of the morpheme parameters, the number of possible inflection points, etc. Otherwise, you need sufficiently advanced software tools to automate word class identifications and parts of speech tagging. But this is not easy as for Malayalam is concerned. The next morphological complexity measure is based on corpus linguistic parameters. This is a relatively easy and reproducible method which involves counting word instances and calculating its probabilities, etc. And this requires no linguistically annotated data too, which means it can be practically done easily if you have a sufficiently large corpus. In our experiments, we have followed the corpus linguistic parameters. And there are sufficient studies in literature that shows that the linguistic typological measures of morphological complexity are well correlated with the results as obtained from corpus linguistic studies. So we have measured type token growth rate, type token ratio and moving average type token ratio for Malayalam to compute the morphological complexity. We have used the corpus of Malayalam text of Wikipedia articles curated and published by Swatantra Malayalam Computing, a language technology initiative working in India. The SMC corpus consists of 62,000 plus Malayalam Wikipedia articles, its formal encyclopedic Malayalam of natural text, and after removing foreign language words, numerals, punctuations, etc., there were 8.14 million words in the resulting corpus. So, we measured various type token parameters. Let's define types and tokens in a brief manner. Type refers to an element in the set of all distinct word forms in a corpus. And token represents an instance of a type in the corpus. So, in the sentence, to be or not to be is the question. We have 7 types and 9 tokens, resulting in a type token ratio of 7/9. On the right side we have a rough translation of the same sentence here in Malayalam, and it consists of 4 distinct word forms, that is 4 types, and there are 4 tokens also, resulting in a type token ratio of 1. So, morphological complexity is directly related to the value of type token ratio. Higher the type token ratio, higher is the morphological complexity of the language under consideration. This graph indicates the plot between the type count and token count for Malayalam from the corpus we considered. For a morphologically complex language, there are more diverse word forms present in the corpus. And as we move along the corpus, we continue to observe newer and newer types, and resulting in a steadily rising type token growth rate curve. Here we have 1.2 million unique word forms or types, corresponding to 8 million of the total tokens. For a morphologically less complex language, the curve often becomes saturated and becomes horizontal if we check the type token growth rate graph. Next is the type token ratio graph, where we have taken the token count on x-axis and the TTR value on y-axis. So first we consider 1000 tokens, and there are 805 distinct word forms or types in that, resulting in a type token ratio of 0.805. And by incrementally increasing the token count, we have reached a type token ratio of 0.157, somewhere here. So type token ratio is a parameter that is dependent on the text length or the total token count under consideration. So if you are going to compare the type token ratio of 2 different languages to compare their morphological complexity, we must make sure we are comparing it on the same number of tokens. Here is what we did to compare the same. We have computed the type token ratio for Malayalam for different token counts as seen from this graph, and we have compared it with the reported values of type token ratios of different Indian languages. We have made comparisons with Marathi, Hindi, Tamil, Kannada and Telugu along with English, and the values shown in this graph for non-Malayalam languages are obtained from the paper by Bharadwaj Kumar and others published in the International Journal of Dravidian Linguistics. The graph clearly shows a higher level of morphological complexity for Malayalam when compared to other Indian languages. On comparing the same value of TTR, same parameter of TTR with other European Union languages, we obtained this comparison graph pairs. Here, the comparison is made with Malayalam to European languages such as Finnish, Estonian, Czech, Slovak, English and Spanish. The values of European language TTR were reported by Kettunen by evaluating the European Union Constitution corpus. And here again you can see the morphological complexity of Malayalam in terms of TTR is quite higher than other European languages, of which most of them are morphologically complex in nature. So TTR being a parameter dependent on text length, let's consider another parameter called moving average type token ratio, which is independent of the token count or text length. It's obtained by computing the type token ratio over a fixed window length. Here we have taken the window length to be 500, and we compute the TTR of first 500 tokens of text in our corpus. Move the window to a next position, compute the TTR again, and repeat moving the window until you reach the end of the corpus. And taking the average of all these TTRs will give you moving average type token ratio. And this is another parameter that is often used to measure morphological complexity of languages. This graph shows the moving average type token ratio of Malayalam computed over different sections of the corpus under consideration. So it steadily shows some value close to 0.8. On computing MATTR of Malayalam, over 0.1 million tokens of our corpus resulted in a value of 0.806. And Kettunen has reported MATTR values of different European Union languages based on MATTR calculated over the European Union Constitution corpus, and these values were smaller than the value we obtained for Malayalam, again indicating a higher level of morphological complexity for Malayalam. So, to conclude, we have defined the morphological complexity of Malayalam in terms of corpus linguistic parameters, and on comparison of these values with other Indian and European languages have shown that the morphological complexity of Malayalam is quite higher than these languages we considered for comparison. And what does it imply? It simply implies that the computational linguistic methods developed for high resource languages like English, which are not morphologically as complex as Malayalam, they do not transfer necessarily well in the scenario of a morphologically rich language. So that's all. All the data and the analysis we have done in this paper are available in the repo shown in this slide. And thanks for listening. These are my references. And thank you once again.